at Toyota when the changeover time for a machine was reduced from 100 minutes to 3 minutes. The principles of the SMED system can be applied to any changeover operation. One characteristic of lean production systems is multiple manufacturing cells. The cells contain the machines and tools needed to process families of parts having similar processing requirements. In essence, the cells are highly specialized and efficient production centers. Among the important benefits of manufacturing cells are reduced changeover times, high utilization of equipment, and ease of cross-training operators. On the other hand, the occurrence of quality defects during the process can disrupt the orderly flow of work. Thus, quality improvement focuses on finding and eliminating the causes of problems so they do not continually crop up. It also minimizes defects through the use of automation, which is also referred to as judoka, that involves automatic detection of defects during production. It consists of two mechanisms, one for detecting defects when they occur, and another for stopping production to correct the cause of the defects. Work or production flexibility is another one. The overall goal of this system is to achieve the ability to process a mix of products or services in a smooth flow. Process design can encourage production flexibility and reduce bottlenecks in a variety of ways. Bottlenecks are defined as department, facility, machine, or resource already working at its full capacity and which therefore cannot handle any additional demand placed on it. Also called critical resource, a bottleneck limits the true output of associated resources. A balanced system also helps to achieve a rapid flow of work. Through the system, time needed for work assigned to each workstation must be less than or equal to the cycle time. The cycle time is set equal to what is referred to as the takt time. It is the cycle time needed in a production system to match the pace of production to the demand rate. It is sometimes said to be the heartbeat of a lean production system. Once the takt time for the system has been determined, it can be used to determine the time that should be allotted to each workstation in the production process. Using the takt time results in minimizing work-in-process inventory in instances where demand is stable and the system capacity matches demand. Inventory storage also counts. Lean systems are designed to minimize inventory storage. It is a waste. Inventories are buffers that tend to cover up recurring problems that are never resolved, partly because they are not obvious and partly because the presence of inventory makes them less serious. For example, when a machine breaks down, it won't disrupt the system if there is a sufficient inventory of the machine's output to feed into the next workstation. The use of inventory as a solution can lead to increasing amounts of inventory if breakdowns increase. Similar problems with quality, unreliable vendors, and scheduling also can be solved by having ample inventories to fall back on. One way to minimize inventory storage in a lean system is to have deliveries from suppliers go directly to the production floor, which completely eliminates the need to store incoming parts and materials. The last one is the fail-safe methods. It is also called poka-yoke, which refers to building safeguards into a process to reduce or eliminate the potential for errors during a process. An example of this includes detectors at department stores that signal if a monitoring tag hasn't been removed from an item, and other devices that won't operate if an incorrect password is used, and so on. The third building block is personnel or organizational elements. There are 5 elements of personnel and organization that are particularly important for lean system. Workers as assets, cross-trained workers, continuous improvement, cost accounting, and leadership or project management. A fundamental tenet of the lean philosophy is that workers are assets. Well-trained and motivated workers are the heart of a lean system. They are given more authority to make decisions than their counterparts in more traditional system, but they are also expected to do more. Another kind is cross-trained workers. Workers are cross-trained to perform several parts of a process and operate a variety of machines. This adds to system flexibility because workers are able to help one another when bottlenecks occur or when a co-worker is absent. It also helps line balancing. Furthermore, workers in a lean system have greater responsibility for quality than workers in traditional systems, and they are expected to be involved in problem solving and continuous improvement. Problem solving is a cornerstone of any lean system. Problems that occur during production must be dealt with quickly. Some companies use a light system to signal problems. In Japan, such a system is called andon. The purpose of the light system is to keep others in the system informed and to enable workers and supervisors to immediately see when and where problems are occurring. Toward the end, a central theme of a true lean approach is to work toward continual improvement of the lean system, reducing inventories, reducing setup time costs, improving quality, increasing output rate, and generally cutting waste and inefficiency. Another feature of some lean system is the method of allocating overhead or cost accounting. Traditional accounting methods sometimes distort overhead allocation because they allocate it on the basis of direct labor hours. However, that approach does not always accurately reflect the consumption of overhead by different jobs. Conversely, other costs now represent a major portion of the total cost. Furthermore, the need to track direct labor hours can itself involve considerable effort. One alternative method of allocating overhead is activity-based costing. It is designed to more closely reflect the actual amount of overhead consumed by a particular job or activity. It first identifies traceable costs and then assigns those costs to various types of activities such as machine setups, inspection machine hours, direct labor hours, and movement of materials. Specific jobs are then assigned overhead based on its percentage of activities they consume. The last element is the leadership or project management. Managers are expected to be leaders and facilitators, not order givers. Lean encourages two-way communication between workers and managers.
The next building block is the manufacturing planning and control. There are 7 elements in this building block. These are the level loading, the pull system, visual system, limited work in process, close vendor relationship, reduced transaction processing, and preventive maintenance and housekeeping. The first element is the level loading. Lean system place a strong emphasis on achieving stable daily schedules, and because of this lean system provides a rate-based production schedule. Moreover, once established, the production schedules are relatively fixed over a short time horizon. Suppliers like the level loading because it means smooth demand for them. This element requires a smooth production. For example, when a company produces different products, it is advisable to produce it in a small lot to maintain flexibility and minimize the work in process, and also to spread the production throughout the day to achieve smooth production. The next element is the pull system. The term push and pull are used to describe two different systems of workflow. In traditional production, push system is used meaning the work in one station is pushed to the next station when it is done. Conversely, the pull system, the output in the station is pulled only when it is needed to the next station. The final operation is pulled by the demand of the consumer or the master schedule. Communication is also needed. It moves backward throughout the system, from station to station, meaning each station communicates its need for more work to the next station, assuring supply is equal to the demand. Pull system is simply next step demand workflow system. The third element is the visual system. This element is simply used literally a visual, and this is called the Kanban. Kanban is a Japanese word meaning signal or visual records. This is a cart or any other device that communicates demand for work or materials from the preceding station. This Kanban is the authorization to move or work in parts. There are two types of Kanban, the one that signals the need to produce and the one that signals the need to deliver the parts to the next workstation. These are called the production and the conveyance Kanban. One simple example of the visual system is in the small stores. The clerk walks in the aisles daily to check for the empty spaces. He deduces what is sold and orders replacement. Another element is the limited work in process. The movement of materials and work in process in a lean system is coordinated so that they will arrive at each system as they are needed. There are two general approaches in controlling the work in process. One is the Kanban's control, which focuses on individual workstation. With Kanban, upstream work is blocked and processing is stopped fairly quickly and also focuses on specific parts. The other approach is the ConWeave approach or the constant work in process. It focuses on the system as a whole. In this approach, when the job exits the system, a new